Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 10G assignment. First one we're going to take a look at here is number 1. Box contains 7 red and 3 green balls. 2 balls are drawn one after another from the box without replacement. That's going to be important in here. Determine the probability that both are red. So, we got a box here with 7 red, 2, 3, 4, 5, 6, 7, and 3 green, right? 2 balls are drawn one after another without replacement. Determine probability that they are both red. So the probability of getting red on the first draw is going to be there's 7 available out of a total 10, right? Now, since it's without replacement, that means on the first one, we are going to pull one of those red balls out, and it is no longer going to be in there. So that means on the second draw, there's only 6 red balls left out of a total 9 total balls left in there. So 2 balls are drawn one after another in the box without replacement. Determine the probability that both are red. So this has to happen and this has to happen. So we got to multiply those together. You can simplify these first, or just multiply straight across and try to simplify afterwards. Or really officially on the IB test, you don't even have to simplify, but back of the book is going to give you simplified answers. So let's see, if we do this straight across, we're 42 out of 90. If we put that in here, let's see, if we do 42 divided by 90, well, really we know from over here we can divide both of those. Oh, oops. 42 divided by 90. If we put both of those are divisible by 3, so we could have simplified it there first. That didn't help us, so we do this. 42 over 90. So you can kind of see why it'd probably be easier if you just simplify it first. 7 out of 15. Again, this is an okay answer. I would not mark that wrong. This is just a little bit more simplified. It makes it a little bit easier to understand. Okay? Moving on to number 3, box contains 12 identically shaped chocolates, of which 8 are strawberry creams. So we got 12 chocolates, 8 strawberry creams. 3 chocolates are selected simultaneous from the box. Determine the probability that none of them are strawberry creams. So we got a box, and we've got 1, 2, 3, 4, 5, 6, 7, 8 strawberry creams. We don't even know what the other ones are. So let's put those as other. 1, 2, 3, 4 more, because 8 and 4 gives us our 12. Determine the probability that none of them are strawberry cream. So the probability on the first, we're drawing 3 chocolates. So first, second, third. I just kind of like to organize it so you can see what's going on here. Probability of not getting a strawberry cream on the first draw would be any of these 4 are what we want out of a total of 12. Okay? Now, we've taken one of those out, so that means the second draw, there are going to be still 3 out of 11 of them are not going to be strawberry creams. Okay? And then, so we take another one of those out for the last draw, and now we're down to 2 out of 10. Okay? Now, all of these things have to happen, so it's and in between there. So we're going to multiply these together. But really, first, I'm going to simplify this. I know that 4 times 3 is 12, so those simplify out. Those all turn into 1s. 2 over 10 is the same as 1 over 5. So really on the top, we get 1 times 1 times 1, which is 1, over 1 times 11 times 5, which is 55. So there's a 1 out of 55 chance that none of them are strawberry creams. Okay? All right. Moving on to 5. Hat contains 7 names of players in a tennis squad, including the captain and the vice captain. We've got 7. If a team of 3 is chosen at random by drawing the names from the hat, determine the probability that it does not contain the captain or the vice captain. So we've got ourselves our box of 7 names. So we've got the captain and the vice captain, and let's just say we've got 5 other players, right? So what's the probability that it is not going to contain, if you draw 3, first choice, first draw, second draw, third draw, what's the probability that it does not contain the captain? The captain or the vice captain, so neither of these. So that means we have to draw one of those 5 out of a 7 total. But once we draw one of those out, you're not going to redraw the same person, so we got to take one out. So that means on the second draw there are 4 left out of a total 6. And then again we get rid of another player here. And then that leaves us with 3 players out of a total 5 in there. So these have to all happen. So we multiply those together and away we go. First thing I'm going to do is try to simplify here. So 3 and 6 reduce down to 2 and 1. Let's see, these 5s will cancel each other out. 4 over 2 turn into 2 over 1. So now we are left with 1 times 2 times 1, which is 2, over 7 times 1, which is 7. So 2 out of 7 chance that if you choose 3, it will not contain the captain or the vice captain. Okay? All right, moving on to number 9. Probability of rain tomorrow is 1 out of 5. If it rains, Mudlark will start favorite in the horse race with probability 1/2 chance of winning. If it's fine, meaning it's not raining, that means Mudlark only has a 1 in 20 chance of winning. Okay? Display the sample space of possible results for the horse race on a tree diagram. So, tree diagram starts with some branches here. So let's go, probability of rain tomorrow is 1/5. So let's go with rain versus not raining. Okay? So probability of rain is 1/5. So 1/5, or you could put 0.2 is fine. Probability of not raining is the other 4 out of 5. Okay. And then let's see. And then it's winning versus not winning, right? So we get a win or loss, and then win or loss. So if it's raining, probability is 1 out of 2 chance of winning if it's rain. So 1 out of 2, which means the other 1 out of 2 they're going to lose. Okay. If it's not raining, they've only got a 1 out of 20 chance of winning, which means the other 19 out of 20 chance will be a loss. Okay, so there's our tree diagram info. Determine the probability that Mudlark will win tomorrow. So if we're looking for Mudlark winning, that's this right here. So it has to be those two. Or it can be those two together, right? Because it has to end up with a win for Mudlark either way. So we'll do probability of it's going to be much better chances if it's raining, right? So we've got 1/5 times 1/2 to give us 1/10. Okay, and then we also have this one. We've got 4/5 times 1 over 20. Let's see, the 4 and the 20 reduce down to 1 and 5, so that's a 1 out of 25. Okay, now either one of these situations can happen, so really what we got to do is we got to take 1/10 plus 1 over 25, add those together, and away we go, right? I'm going to take the easy way out, and I'm going to do 1/10 plus 1/25. You can also get these to be common denominators, but don't have to, because this will help us get it all figured out. So that would be a 7 out of 50 chance, which really, if you double that, that's 14 out of 100. So there's a 14% chance that Mudlark is going to win. Okay, let's take a look at one last one here. Number 11. Jar A contains 2 white and 3 red discs. So here's jar A. We got 2 white and 3 red discs. Jar B contains 3 white and 1 red disc. A jar is chosen at random by flip of coin, and 1 disc is randomly selected from it. Determine the probability that the disc is red. So let's do this. Let's do ourselves a little tree diagram. So we're going to flip a coin, and we're either going to choose from jar A or jar B. Since flip of a coin means 1/2 of the time it'll be A, 1/2 of the time it will be B. If it's A, we're either going to get, let's do this. So we stay in the same order as that. Doesn't matter, but just looks a little nicer. We're going to do probability of getting white or red, and then same thing here, probability of getting white or red. So if we're in jar A, probability of getting white is 2 out of 5, which means the other 3 out of 5 times we'll get red. And then for jar B, 3 out of 4 of them will be white, where that means the other 1 out of 4 will be red, right? So determine the probability that the disk is red. So that's where we want to end up with this here. So we have that path and this path. Either one of those will work, right? So this path is 1/2 times 3/5. And then this path here is 1/2 times 1/4. Okay, so again, this can happen or that can happen. So if we do this here, that's 3 out of 10. And this is 1 out of 8. Right, so we would want to add those together. So again, if we've got the technology, let's use it. 3 over 10 plus 1 out of 8. And we get 17 out of 40. So 3 out of 10 plus 1 over 8 is 17 over 40 when it's reduced down. Okay? Okay. That's all we have for the 10G problems. If you have any further questions on any of these, please feel free to ask in class. Thanks.